Hi, good morning. So, in this video, we are going to learn how to describe a motion. Say if I have a man here and he's moving with acceleration 2 meters per second square. Okay, just remember acceleration means the increase of speed. Okay, so he's going to move faster and faster. So let's have a look. Yep. Okay, so if you say that man doing this motion, how do we describe it? Now, uh, in science, in physics, how I describe it will be I just tell everyone that he start from rest, okay, he start from stationary and moves to the right with an acceleration of 2 meters per second square. Okay. However, okay, the most, what I can say is the most, sorry, okay, the most effective ways of describing a motion is using graphs. Say if I gave this guy acceleration, okay, and let's have a look at the graph. Yep, let me stop here. Yep, we can say that. So if we zoom in the graphs, okay, his acceleration is 2 meters per second square, constant over the period of 4 seconds. Okay, sorry. And his velocity is increasing because he accelerates, and his position is increasing uh, at a higher rate. Okay, so that's basically um, graphs. Yeah, graphs is one way of explaining describing motion. So this is why graphs are important. It it describes motion in explicit details. So if I go back to the graph, okay, I want to know what's happened to the man when the time was 2 seconds. So I look at the graph when time is 2, his acceleration is 2 meters per second, his speed is approximately 4 meters per second, and his position will be minus 6 meters from there. So he traveled from minus 10 to minus 6 in 2 seconds. So, yep, it gives us explicit details of a motion. Okay. Now, in motion, there are 3 types of graphs. So we have, let's start from the beginning. We have the position time graph, okay, or displacement time graph. Okay. Position and time. Normally, the position will be measured in meters, the time will be measured in seconds. Now, the second type of graph is a more common type of graph, is the velocity time graph. Okay? Velocity in meters per second and the times in seconds. And the last graph will be the acceleration time graph. Okay? Acceleration in meters per second square. Remember the unit of acceleration, and the time in seconds. Okay. Now, but what we can learn from those 3 types of graphs is that, believe or not, these 3 types of graphs are connected. Okay, they are somehow related. So, for example, let me use let me use the previous example. Say if an object is moving with an acceleration of 2 meters per second square over the time of, say, 4 seconds. Okay. Now, so what I can tell you is, okay, what I can tell you is the area under the acceleration and the time graph is going to be, yeah, if we find out the area under this graph here, okay, it's going to be the velocity. Okay, so if you do it, say 2 times 4 will be 8. The area under this graph is 8. So when the time is 4 seconds, its velocity must be 8 meters per second. There. So that's the relationship. Okay. So the area under the acceleration graph gives you velocity. So just let me write it down. Area under graph. Okay. Now, if you want to try something else, okay. Say I give you another example. Say let's look at 2 seconds. Okay. At time equals to 2 seconds, okay, the area under this graph will be 2 times 2 will be 4. So the the velocity must be 4 meters per second. So in other words, the area under acceleration and the time graph give you a velocity. Okay, so you can compare it with the graph we have here. Okay, now, okay. Now let's look at the velocity and the time graph. Okay. An object, like what's happening previously, an object start stationary, start at 0 speed, start from rest. And we subject it to acceleration, it's going to move faster, faster, and faster, and faster. Okay. So its velocity is going to be increasing, increasing, and increasing at a constant rate because the acceleration is constant. So we ending up with a straight line graphs like that. Okay. Now, the beautiful thing about velocity time graph is, okay, now if you measure, okay, if you calculate the area under the velocity and time graph, you can find the position. Okay? You can find the displacement. You can find how long it traveled. Okay? For instance, so at 4 seconds, its velocity is 8 meters per second. We have a triangle here with a length of 4 and a height of 8. If you use your mathematical skills, if you try to find the area of triangle, okay, it's half base times height. Okay. So half times 4 times 8, okay, it's going to be 16. Okay. Half, yep. So at time 4 seconds, the object must traveled 16 meters. Yep. So what we can say is, okay, the area under, okay, velocity and time graph gives me the position, gives me how long it traveled, gives me the displacement. Okay. So if you can, yep, if you look at it, the area under this part must be how much it traveled from the initial point. So if yep, just let me redo the graph here. Okay, we're going to have a parabola, something like this. That's 16. Okay. So if you do it here, at 2 seconds, the area, this little triangle have an area of 4 times 2 times half, which is 4 meters. Okay, so that's the beautiful thing about the graphs. Now, we haven't finished yet. Okay. If you look around, sorry, if you look the other way around, okay, what I can tell you is the gradient. Okay. The gradient of position time graph, right? The gradient of position time graph. Well, I am assuming everyone doing math method. Okay, so when I'm talking about gradient, I'm talking about the linear lines on it. I will do some examples. The gradient of the position time graph gives me the velocity. Okay, the gradient. Okay. Similarly, I have a straight line here. Okay. The gradient, okay, rise over run. If I'm going to measure the gradient, okay, 8 divided by 4, okay, which is 2, gives me the acceleration. So this is the relationship between graphs, position time graph, velocity time graph, and acceleration time graph. Now, yep, okay. Now, the tip, a tip I can give you is always just remember, okay, Isaac Newton. Newton is the one who invented calculus in math. He invented calculus to solve physics problem. And in calculus, we always interested in two things. When we have a graph, we always interested in the gradient and in the area under the graph. So this here shows us the relationship between acceleration, velocity, and position regarding in regards to the use of graphs. Okay, now I'm going to go through it one more last time. Okay, the area on the acceleration and time graph gives me velocity. Okay. The area on the velocity time graph gives me position or displacement. Okay. The other way around is the gradient of position time graph gives me velocity, and the gradient of velocity time graph gives me acceleration. So what I'm going to ask you to do is please copy down this in your notes or write this down in your cheat sheet. Okay.